everyone, I'm Jean with the SeaDoc Society, and I, along with Joe T. Where's Joe T?
In the back here.
Back there. Joe Gatos is here. Laura from Camper Kyla, and Jenny from Darville's Bookstore would like to welcome you to tonight's lecture.
Bad mic. Hey, Jean.
Give me the tightest.
Jean, that mic's bad.
Okay.
Tonight's
lecture
Turn it off.
Dr. Milton Love, Fishes of the Salish Sea, and then some extras.
Yeah.
You guys are in for a great treat tonight.
I hope so, because I don't know what I'm going to say.
So this is our 11th year of doing the Marine Lecture Series, and it would not be possible without our sponsors. Tom Maverna, Deer Harbor Charters, Barbara Brown was here tonight, Barbara Bentley and Glenn Petrich, Dean and Audrey Stuckey, West Sound Marina. So if you guys see them around town, please thank them. I'm also in the process of lining up our Marine Lecture Series for 2013-2014. So if you're interested in being a sponsor, please see me after the lecture, as well as if you have any ideas for topics. I'm open for ears. So there's information about SeaDoc across the table from where Jenny has the books. Feel free to sign up. You can follow both Camper Kyla and SeaDoc on Facebook. And I think that's it. I'm going to leave it up to Milton.
Why are you looking at me? How would I know if it's it? I mean,
Well, because I'm not going to tell anything about it.
okay, well, thank you. That's a long way up. That's a long throw. Can we get a few lights off so that it's dark, or is this impossible?
This is as dark as we get.
That's fabulous. Thank you very much. Well, I feel great. At least I won't be bitten by a vampire. So fabulous. So very briefly, my name is Milton Love. I'm a research biologist at the Marine Science Institute, University of California, Santa Barbara. And I've been basically doing research on the fish of the Pacific coast since I was like 6, probably. And my dad took me fishing on the Malibu Pier. Soon after that, according to family lore, I declared I was going to be a fish biologist. And I have such little imagination, I never changed my mind. So, in the last 15 or 20 years, most of my research involves, as I think I mentioned, looking at the role that oil platforms off California might play as fish habitat. So we take a submarine down, a little thing the size of a phone booth, and count fish. That's much of what we do. So I'm going to talk tonight about interesting fishes, most of which live in the Salish Sea, some of them don't, and that have interesting attributes or habits or whatever. If you have questions, and it's like you're going spilkus, as my mother would say, if you're going nuts and you have to ask the question, raise your hand. But it's better to ask afterwards, just because some of you have leaked bladders and you have to leave. I mean, that's the sense I get of this crowd. So these are silver salmon and spawning colors. I'm not going to talk about salmon because I actually don't like salmon particularly. I think they're like overrated fish. And I actually think they're wussy fish. My feeling is when you catch a fish, if it can't hurt you, then it's a wussy fish. I'm not interested in you anymore. And the most a salmon could do, I expect, it could give you a hickey, probably. It's like suck on your cheek or something like that. So about 7 years ago, Ray Troll. You guys know who Ray Troll is? The Alaskan artist, spawned till he died, stuff like that. So he calls me up and he says, I understand you're going to be in Sitka for a conference. That's near Ketchikan, where he lived. He said, we have monthly public lectures. Would you come and give a public lecture about fish? And he said, you can stay at my house. I'm fine. So I said, yeah, sure. And about a week before I go up there, I get a call from the newspaper in Ketchikan. They want to do a little article about me. And I go into my little riff about how salmon are wussy fish and on. And so I get to the airport in Ketchikan, and Ray picks me up and he goes, we got a problem. I'm going like, yeah, well, what's the problem? He goes like, well, you offended the whole town. Really? I said, well, what do you want me to do? He said, I want you to apologize. I'm going like, how do you apologize to the whole town? He said, I've scheduled you for 4:30 on the NPR show. And you're going to apologize to the whole town. I'm going like, okay. So, because I'm thinking like, I had 4 years of therapy. I can apologize to anything. Hardly matter. So I got on there. It was actually to publicize my talk, but I did apologize. I said, I understand it's Sam, all the blah, blah, blah. But I thought to myself, yeah, but they're still wussy fish. So that's it for salmon. Next, oh, me. No, I can do it. I can do it, maybe I can do it. I did. Okay, so I'm going to go through fishes kind of by their habitats. So the first ones are these kind of open water fishes, fishes that you associate less with structure and more with the pelagic realm. These are Pacific sardines, which are, in certain periods, extremely abundant into Washington and British Columbia, but in certain periods they're not. And basically, off the Pacific coast, we go through periods of cold water and warm water. They alternate, and it's about a 20 to 30 year period of cold water, and then 20 to 30 year of warm water. Sardines tend to like warm water, and we produce well during that period. And then we get that shift, and they all of a sudden don't reproduce well, and the population starts to contract all the way down into Mexico. And during a real cold water period, there'll be almost no sardines on the entire Pacific coast. So what happened in about 1910 is we had a lot of sardines all up and down the Pacific coast, a lot of canneries open, Cannery Row in Monterey, all those canneries based on sardines. And then the population collapsed in about 1947, partially due to overfishing, but partially due to a change in the temperature of the water. And basically, those sardines would have collapsed anyway. If no one was fishing a single sardine, they would have collapsed all by themselves because their reproductive success was nil. We just sped up the process. And it turns out that a lot of those sardine herring-like fishes, they go through these same boom and bust cycles. The next slide is, oh, that's me. No, how about doing the slides? Okay, I'll do the slides, thank you. No, because now you're crouching down and I'll feel guilty for the next hour. Why don't you get a chair? I'll feel better. Jewish people should not be allowed any power whatsoever. They're like guilty about everything. So this is the Pacific herring. This is kind of your equivalent of the sardine. You have sardines, but they're not abundant. Herrings are one of the major forage fishes in your area and all the way up, well, actually, all the way up into the Beaufort Sea. If you go all the way onto the Canadian Beaufort Sea in the Arctic, they're herring out there, very abundant. Herrings are different than sardines in one major way. Sardines, when they reproduce, they have what's called broadcast spawning. Basically, the males and the females just release sperm and milk, and everybody hopes for the best, right? But in herring, the female herring glom their eggs. They lay their eggs on substrate basically in the barely subtidal. And that could be algae, it can be rocks, it can be almost anything. And then when this is done, or during that process, the males will then en masse spray sperm into the water. Next slide. There's an example. All of that white stuff is herring sperm. Right? And every time I see this, it makes me proud to be an American. Because communists can't do this kind of stuff. Of course, the ironic thing is that this was in Canada, but you know what? It's close. It's close enough. Canada is the United States with better healthcare and fewer guns. So it's like the same kind of thing. So that's the reason, a line like that is the reason I'm no longer allowed to give a talk at the Monterey Bay Aquarium. One too many little asides like that, and I offended a fair number of conservative docents, and that was it for me. So anyway, that's kind of what it looks like. Next. So this is one of your other big forage fishes, the sand lance. Really interesting behavior. Sand lance, in many places, spend the winter months buried in the sand. And sometimes they'll actually bury in the intertidal. And I don't know if they do it here, but in Alaska, southeast Alaska, very frequently you will see at low tide, you'll see golden eagles and bald eagles walking along the beach. And what will happen is when they apply pressure to the sand, a sand lance will pop up and they'll eat it. So they walk up and down the beaches waiting for sand lances to pop up. So it was at one time thought that almost all sand lance habitat was in relatively shallow water. And then Gary Green and a graduate student, they actually found a big concentration of them here in 200 feet of water, which was like completely unknown. There's just, I think one of the themes I'll try to bring up is there's a lot that's not known, even among fishes that you would think, well, shoot, everybody studied them. It's not true. There's always something that's kind of a surprise. You work in the ocean, it's one long, frustrating, surprising sequence of events. So this is another one of those species where kind of keystone species, if they didn't exist, a lot of large predatory animals pinnipeds, sea lions, and so forth, would really be in severe trouble. There's a lot of animals that depend on herrings, some of the smelts, and sand lances in particular. This is our equivalent in a way. This is the California grunion, which lays their eggs on wet sand, and from about Monterey south. They always do it in the spring and summer. It's always at night, and it's always on the new moon and full moon, the highest tides. Basically, the animals come up, and usually it's around midnight, something like that, and they will wiggle their way up as high as it's wet. And then, next slide. I don't have a pointer, but what happens is the female will go vertical and bury herself mostly in the sand. See the animal at the very bottom there? That's the female. And then the males come over and spray her with sperm, and the sperm goes down her body and hits the eggs that have been laid. Then everybody leaves, and the waves cover over the eggs. 2 weeks later, next set of high tides, the water agitates the eggs, and they hatch, and the larvae then swim out to sea. You can actually get a male grunion to mate with a stick. Now, most of us are saying, like, you know, after a couple beers, some sticks look okay, right? But it's more than that. It's more than that. It's more than, you know, your stereotypes about males, all of which are true, by the way. So basically, here's the thing. You can actually take a dowling. The Boyd Walker, who studied this at UCLA, he would take dowling. And he put a stick down and he'd wiggle it. And basically, if you think what the males are keying in on a flat sandy beach, there's nothing vertical, normally, because it's like flat and sand. But the only thing that is vertical are females. So there's this vertical thing that's wiggling, and there's been like millions of years of selection to hit that thing with sperm. And so if you make a piece of wood, you know, that's what they're keying in on, is the verticality and the wigglingness of it. Here's another example. This is a tube snout. Tube snouts are very abundant in your area. This was actually taken, I think, off Whidbey Island. That's a male, and those are eggs, the white things there. And the conventional wisdom was the female lays the eggs, usually like right there on algae, and the males kind of guard them. They fertilize them and guard them. But it turns out that in a lot of cases, you go down, you see the eggs, and there's like no fish around. So now it's up in the air whether males always guard them or not. Like another thing that someone just kind of came across. Next. Sharks? What kind of shark is that? Yes, it's blue, right? It's a blue shark. So blue sharks are probably, not necessarily in the sound here, but once you get off the coast, they are one of the most abundant sharks that you will see, just on a daily basis. The blue sharks you see off here are primarily adults. They come up as the water's warm, and as the water's cool, they will retreat. Off Southern California, we have them all year round, mainly juveniles, and because the adults are kind of trucking through Southern California and up into the area. They'll go all the way into the Gulf of Alaska, like by August, something like that. Like most sharks, they are not hazardous to humans. There's only a handful of sharks that actually bite people. The only shark attack that's ever occurred on the Pacific coast was a guy off Anacapa Island off California. He was chopping up fish, throwing them overboard, and the sharks all were going like berserk, and then he jumped in the water. And he was bitten. You know? It's like, that's not like karma, right? It's not like you were Mussolini in a previous life. I mean, that was like stupid. If you actually look at their teeth, they don't even have the dentition of some, they feed on fish and squid. Next. So I mean, this shark does. So that shark is a white shark. You have white sharks here. They actually have found white sharks all the way to the Bering Sea. And they're pretty abundant off Washington. On the Pacific coast, if a person is bitten by a shark, almost always it's a white shark. They feed, once they get about 7 feet long, they stop feeding on fish, and their teeth change. They go from really narrow, smooth teeth, fish-eating teeth, to triangular serrated teeth, which are used for cutting things. And they feed primarily on pinnipeds, sea lions, and the like. And the question always is, when a person is bitten, does the shark think that you're a sea lion or not? And it may be that they don't. They're kind of famous for like testing things. They'll bite things, and if it doesn't seem right, they'll stop. And so a lot of people who are bitten, they have a chunk taken out of them, but then the shark says, whatever, and hauls away. But there's no question that this is the most dangerous shark. Have a very interesting behavior. Most of the sharks that are off the Pacific coast are on the Farallon Islands off of San Francisco, places like that. They'll be there, the adults will be there in the fall and winter, and sometime in the winter, almost all of them swim like almost in a straight line to Hawaii. And they'll go about 2/3 of the way to Hawaii, and they'll stop for like 2 or 3 months. And then, as the season changes, they'll come right back to the Farallon. No one knows what they're doing out there. We know that they're there because we acoustically tag them and track them. But no one knows what they're doing. They may be mating there, they may be feeding there. They're not at the surface either. They're down a couple hundred feet. So no one knows what they're doing. There was one white shark that was tagged off South Africa, female, and it made a beeline to Australia and stayed there for a couple weeks, and then it made a beeline back. We think it gave birth in Australia. Why you would have to do that, I don't know. These sharks are cool. Next. This is not a good slide, but it's the best image I've ever seen of this. This is a salmon shark, which is related distantly to a white shark. It's one of the most abundant large sharks you have here. What's interesting about them is that they live both in the eastern Pacific, on our coast, and on the western Pacific off Japan and Korea. Almost all the sharks on our side of the Pacific are females, and almost all the sharks on the other side are males. And it looks like they meet in the Gulf of Alaska, they mate, and they split apart again. And the females will swim, many of them will swim, all the way down to Southern California or northern Baja California to give birth. And then they swim all the way back. Very cool. Next. Other pelagic fish, this is the albacore, the white-meated tuna. Very nice, typical pelagic fish. There's been huge amount of natural selection for a fusiform body that reduces friction. These fish have to swim all the time. If you hold a tuna underwater, it will drown. They can't pump water over their gills like a halibut can or a rockfish can. So they have to swim with their mouths open continually in order to get enough water over them. An interesting behavior on the part of this animal, they're born, or they're hatched, someplace north of the Philippines, between Japan and the Philippines. When they get about a year old, most of the population swims all the way across the Pacific to northern Baja California, central Baja California. And then they spend the next 4 or 5 years swimming up and down the Pacific coast, all the way up to, frequently up to Washington and Vancouver. When they get about 7 years old and they're almost mature, they're still juvenile, they swim all the way back to the Philippines and then give birth there. So all the fish that are caught here, even the ones that are like 50, 60 pounds, those are all juveniles. Next. Dogfish, everybody's unfavorite fish. Dogfish is probably one of the most, well, I've been told, one of the most abundant fishes left in the Salish Sea, potentially because everything else everybody wanted to catch, they've caught. So lots and lots of dogfish. These are sharks. They live a long time, over 100 years. They don't mature until they're 25 to 30 years old. It's almost, and then they don't produce many young. It's almost impossible to have any kind of a fishery for an animal that doesn't reproduce until it's 25 or 30 years old. And then doesn't produce 100 pups, produces like 10 or 15 or 20 pups. And that's the reason that every dogfish fishery in history has failed, ultimately, because people catch too many of them. You have to catch small amounts. And it's very hard for fishermen and for fisheries managers to say you can only catch a small amount of something until, like, the population collapses. And you've encountered that in Puget Sound and northern environment. Next. Anybody know what that is? It's a hagfish. Hagfish are, and I'm a biologist, the most disgusting fish on the planet. They have no jaws, so their mouth is open continually. They rasp dead and dying animals, rasp through them, and then go inside and suck out all their insides. That's how they make their living, basically. Next slide, we'll show you the other attribute they have. That is a net filled with hagfish. That's slime hanging down from the net. They produce, I mean, everybody produces slime. I know you're thinking to yourself, hey, look, I had a cold, I can produce slime, whatever. No, this is great slime. This is slime that has like little spider webs running through it. So it's very colloidal. You can actually pick it up. And for a long time, people wondered, like, why do they do this? They have these pores on the sides of their bodies. You can take a bucket with seawater, put a hagfish in about 20 minutes. It's not solid, but it's pretty close to solid with mucus. So people are going like, well, maybe it's defensive, whatever. And about 5 years ago, a couple of Canadian biologists decided, and it's unclear why they decided this, that they were going to anchor a 50-pound leg of a pig off Vancouver Island in about 100 feet of water. This is what happens with too much molsons, clearly. You go like, whoa, why don't we anchor a pig underwater? So, and then they put a tripod down and a video camera, and basically they want to see the scavenging events. And they thought, okay, we'll use a pig. So what they found was that one of the first animals to arrive were hagfish. And the hagfish were chunking away at it, and were producing a lot of mucus at the same time. And then they saw a ratfish come in, and I'll show you ratfish in a second. And the ratfish, their gills got all clogged. They kind of spiraled away and probably died. They were asphyxiated. So it looks like it's a way of protecting your food source. At least that's one of the reasons that hagfish do that. Next. This is a Canadian graduate student. Why are we not surprised? And associated with that, I found this on the web years ago, a bunch of his friends and he made scones out of hagfish slime. So there you go. Next. They said they were all right. This is a midshipman. You guys have midshipmen in the Sound. They spend most of their lives buried in the sand during the day. They come up in the water column and eat krill and other planktonic organisms. They have several attributes that are like hyper interesting. Next. That's the underside, and it's a little hard to see, but you see all those little buttons, all the little dots? Those are photophores. So these animals will glow blue-green, right? But what's really neat is that the animals in Puget Sound don't. They're all the nerves are all right, everything is right about them, but they're incapable of glowing. If you go off Northern California, which is the first place you encounter them again, they can glow again. It turns out, if these animals don't eat a very specific planktonic animal and get a very specific chemical from it, they can't glow. They need that chemical. And that animal does not live in Puget Sound. So if you take one of these animals and you feed it like freeze-dried Nathaphausia, then they can glow. They can get the chemical, but they can't without it. The other thing that's interesting is that they live offshore, and then in the springtime, the males come in and dig nests under rocks and stuff. And they start humming. They actually have muscles attached to swim bladders, so they'll go like, ah, really loud. Really, you can actually hear them from the shore. People used to report in the 1890s hearing midshipmen walking on the shore of Puget Sound and San Diego Bay. So that attracts females. Females come in and lay eggs in this little nest, usually on the underside of it, and the male sprays it with sperm, and then just sits there and waits for weeks for the larvae to hatch, basically, and then swims away. Well, they actually have, there's two kinds of males in midshipmen. There are males that are called bourgeois, and this is true, bourgeois males. And I've just described the behavior of a bourgeois male. Then there are males that are called sneaker males. Sneaker males cannot hum, and their testes are like 8 times the size of a bourgeois male. So what they do is they basically watch. They watch the male humming, they watch the female coming in, they watch the female laying eggs, and right at that point, they dash in, spray sperm in the general direction of the eggs, and scoot away, and wait for another event to happen. And both of them work. There's enough fertilization by the sneaker male to keep those genes in the gene pool. So both methodologies are successful in this case. And it turns out salmon do the same thing. There are sneaker males that don't actually participate in all that digging out crap that salmon do. Lost all interest in those fish. Next. This is a ratfish. Ratfish are related to sharks, skates, and rays more closely than they are to all the other fish. They have a couple of interesting attributes. First of all, they're like cute as buttons. They always remind me of something out of Alice in Wonderland. They have a spine on their dorsal fin that is venomous. It doesn't, I mean, I've been stung by them. It hurts, but you're not going to like die or anything. But the other thing is the males have a little twanger-danger, as we say in biology. Well, it's called a tenaculum. They have a little top knot here. And at the end of the top knot, there's a ball that's got spines on it. And no one until about 8 years ago, 9 years ago, had any idea, well, why, and it's only the male. Why does the male have it? And the next slide I'm going to show you shows you why, but it's a pretty small image. So there's no like laser pointer. Next slide. Okay, so the fish on the right is a female, And the fish on the left is a male. And if you can see, there's a white, like a rod, coming out of the male's forehead. And it's clasping the pectoral fin of the female. So that's what it's used for. These things have internal fertilization. They actually have claspers, which are kind of like penises in a way. And so one clasper has to get into the female, and mating takes a long time. So you have to be paired up for a long time. And this is a way for the male to hold the female in place during this process. And the only reason we know this is, by the way, is that a Canadian amateur photographer took these pictures off of Vancouver. Yeah. Next. Rockfishes, my specialties really has been rockfish over the years. I actually have a tattoo of a rockfish. When I got a tattoo, this is a long time ago, my daughter who was 15, this is the difference in their personality. She said, "Oh, wow, you're going to want 1,000 of them." I'm like, "Oh." And my son who's 11, he said, "Where are you going to get it?" And I said, "I don't know, my arm." And he said, "Well, you can always nod off if you don't like it." And their personalities have held true to this day. So, a number of rockfish just to look at. This is the Puget Sound rockfish. Literally, its name is Puget Sound rockfish. There's some confusion about that. And it's probably the most abundant one, mainly because it's really small. So there's never been a commercial or recreational fishery for the Puget Sound rockfish because they don't get very big and they're rarely caught. You have to work to actually catch one. Next, we've had it in big schools in 80 feet of water, 60 feet of water. This is a black rockfish, again, really abundant in the Salish Sea. Mainly the juveniles, though. You don't see a lot of adults. They don't seem to leave the area, at least historically. But all up and down the Pacific coast, from Central California to about Kodiak Island, this is one of the major near-shore, mid-water rockfishes. Pretty good commercial and sport fishery for it. Next. Yellowtail rockfish, another one that's abundant in our area, but again, in our area meaning here, again, historically it was mainly juveniles. I mean, those animals get about this big, and you don't normally see those in your waters. Those are found once you turn the corner into the Pacific. Next. So they're not kissing each other, I'm just telling you. So that's a quillback rockfish and a copper, both of them historically abundant in your area. Both of them are territorial. So they will stake out pieces of the reef, and any rockfish that comes in, they will normally display first. So they flare out their fins, they open their mouths. And if that doesn't work, they actually lock jaws. And then eventually, one is declared the winner. It's never really, you watch and you go like, I don't know what happened here. Something happened and they know, and that's all it counts. So that's what's going on there, a little fight there. So this is a China rockfish. I mentioned this to somebody. I gave a talk to, what is it? It's not Friends of Puget Sound. It's People for Puget Sound. I gave a talk as a fundraiser for them. Interestingly, there are no people against Puget Sound. Is that an organization? Maybe we should start one. Who knows? So I gave a talk, and it wasn't this slide, but it was at REI in Seattle, and I kind of mentioned that there were China rockfish in Puget Sound. It was like the floodgates of hell opened up. Oh my God, all these emails. There are no China rockfish. How can you say that? I'm going like, geez, Louise, I'm sorry. It's mea culpa. And it turns out that they actually are there, but they're very rare. But the level of intensity is like, you have no lives. Try to spend more time with your kids. I don't know. Oh, this is kind of fun. So this is a juvenile yellow eye rockfish. You guys have yellow eyes. Used to have a lot of yellow eyes, relatively speaking. No one send me an email tomorrow saying, we never had a lot of yellow eyes. Yeah, you did. You actually had a lot of yellow eyes. So that's the juvenile, right? And the next slide. So there's the adults. They look entirely different from one another. Back in the 1880s, 1890s, it was thought there were two species. They looked so different. And then people started getting the subadult, large immature ones, and you can still see those two white stripes, and people going, oh yeah, we made a mistake. These fishes can live at least 160 years. Rockfishes, the oldest rockfish ever caught was and the way you age them is you actually take the ear bones out and slice them, and you count the rings like a tree. The oldest rockfish ever caught was 205 years old. It was a rough-eye rockfish that was caught off Ketchikan. But there are a number of species that live at least 100 years. And as I mentioned at dinner, I once wrote an essay called, You Should Never Eat Anything Older Than Your Grandmother. And, you know, the thought of commercially or even recreationally catching a 100-year-old fish and then killing it, it's like, whoa, man, that's no good to me. Next.
What's down in the corner?
And that was a Lingcod. You want to back up? Right over there in the right corner?
Yeah.
We're going to talk about Lingcod in a moment. You're very astute. So here's another thing we don't understand. Until recently, it was assumed that yellow eyes were either territorial or they didn't like any other rockfish because you would see them individually. But it turns out when you go out to Bowie Seamount, which is located way off British Columbia, you see these. You see like herds of yellow eyes all together. And probably the observation that they don't like each other is an artifact of the fact that there aren't many left. But if you came here 10,000, well not 10,000 years ago, 1,000 years ago, you actually might see them in aggregations instead of like onesies where they're seen now. Next. Okay, so basically, many species of rockfish are overfished in the Salish Sea. A number of ones are officially overfished on the Pacific coast. But the Salish Sea information has come out later than the information about the Pacific coast. And way back, 10 years ago, it was clear that a number of species, populations were declining. And so those lines, as the line goes down, all you have to know is it means there are fewer and fewer and fewer of those species. Each one of those lines is a different species. And it ends in 1995. Around 1995, the federal government just said, hey, we're going to have to do something. And they installed really draconian laws. And I'm showing you this slide and the next one to show you that you can bring fish populations back. But what you usually or often have to do is essentially end fishing for that species. So basically the Fed said, for some species, in essence, ain't nobody catching none of these anywhere on the Pacific coast. They set up whole zones like in California, you cannot fish for any fish on the bottom in water deeper than 300 feet if you're a recreational angler. That's it. 300 feet and shallower you can fish, deeper you can't. So there were these like no-take zones. So next slide. And it actually worked. So this is like 2010, and you can see that virtually all the populations, other than cowcod, which is the one on the bottom, another kind of rockfish, that's my tattoo actually, everything is coming back, almost to the point where the feds can start withdrawing some of these really harsh laws, and you can actually have something of a fishery again for them. So and that's kind of the optimistic thing, is that it's not like hopeless, but it actually, by the time you get to the level it is here or on the coast, man, it's really, we need some severe laws. And then nobody's happy, at all. This fish is not found here. Fortunately, this is the most venomous fish on Earth, arguably. This is the stonefish. Stonefishes are found in the Indo-Pacific. They're tropical fishes, and they, all of their spines are highly venomous. So like how highly venomous? Well, the classic story is a paper, scientific paper written by J.L.B. Smith, who was a South African ichthyologist. In 1951, he was in Mozambique. He had collected a bunch of fish, put them in a tray, and he reached in without looking, and he was stung by a 7-inch long one on his thumb. Okay? He said within 30 seconds, there was this wave of pain that shot up to his shoulder. He had an uncontrollable desire to writhe on the beach in pain. Somehow, he had no memory how, he found himself at a lighthouse. The lighthouse keeper injected his thumb with Novocaine. And that had no effect on the pain. See, that's not good. And then the lighthouse keeper injected him with morphine. Morphine's great. That had no effect on the pain. See, at that point, you start getting depressed. So then, one of the local indigenous folks came in chewing some green stuff and spit it on his thumb. And that had no effect on the pain. So, okay. You've kind of shot the wad, haven't you, right? So, but then his wife came in, and his wife plunged his hand in hot water, and that worked. And that is the treatment of choice for venomous fish stings all over the world, is heat. And the reason is that the venom is a protein. It's actually a rather complex molecule. And if you heat it up, you don't like bust it apart. You actually just change its shape. And it's no longer a venom. It's just a foreign protein as far as your body is concerned. So people who are stung by stingrays, lifeguards put their feet, it's usually their feet, in hot water. And that works. And as an example, next slide. This is as close as we get to a stonefish. This is the California scorpionfish, which is found in California. No one's ever died by being stung, but it hurts, and it hurts a lot. And people have actually had to have morphine for that. I did a study where I tagged them. Basically, we caught hundreds of them at a time in a net, put them in the stern of the boat in big tanks, and then we would hold them down. We had gloves on. You hold them down, and you inject the tag into their bodies and throw them back. And the tag looks like a piece of yellow spaghetti. And it had my name on it, and my phone number, and a code number, 005. Right? So you toss it back, and you hope that sometime in the future, someone else catches that fish, and they call you up, and they say, well, we caught 005 over there, and you know you tagged it over there, so you have some idea of the movements. Well, we got stung all the time. Even though you're wearing gloves, the spines go right through you. And, but we had a pan of hot water literally there, and you just plunge your hand into hot water, and it never hurt any worse than just hitting your, with a pin or something like that. It really was very effective. Working on scorpionfish, by the way, was the source of the third epiphany I ever had in my life. Who's honest enough to know that they don't know what epiphany means? All of you know. Holy guacamole. But for the few of you who are lying, so an epiphany is a salient moment when you have some profound realization. So I'm driving around, this is at the time I'm working on scorpion. I'm driving around, I'm listening to KBC radio, talk radio, this is about 1980, and in LA. And the host had 5 people on, maybe 4 people, all of whom had the same story. They had all been sucked up by flying saucers, by aliens. And the story was all about the same. They were in Taos, New Mexico, having a lime slurpee with Elvis, and then the aliens sucked them up, and then they were in the flying saucer, and then one guy says, and so I was sucked, and then I will shorten this. They poked at his private parts, okay? And so I'm driving along going like, what the hell? Why would aliens come 150 light years just to poke at our private parts? That doesn't seem, I don't know, man. Because at the time, you could get a physiology or anatomy textbook for $5 at a used bookstore, and there's all of our private parts in color. You don't have to poke at them. And then, so I was puzzled by that. And then the guy says, and then they put me back on Earth. I remembered nothing. Until several weeks later, I blew my nose and a ball bearing came out of my nose. And I remembered it all. I'm going like, what the hell? Not only are the aliens poking at our private parts, but they're sticking ball bearings in our noses. So I'm going like, and then I had this epiphany, right? What was I doing with a scorpionfish? I was tagging them, right? And that's what the aliens are doing to us. So there you are, in Taos, New Mexico, having a lime slurpee with Elvis. They suck you up, and they poke at your private parts. And then they put a ball bearing in it, but on the ball bearing is the name of the alien, and the phone number of the flying saucer, and a tag number, 005, right? And they put you back in Taos. You go on a vacation, where to Minnesota, you get sucked up by another flying saucer, and that alien looks and sees the tag and calls saucer up. And saucer up. It was a huge one. Next. Okay, someone asked about that. So these are Lingcod, one of the major, arguably the major commercial and recreational fishes in Salish Sea, and all the way from Southern California, at least to Kodiak Island. Huge range, overfished in many places. So then the question is like, well, where is this picture taken? Because those Lingcod are all 4 to 5 feet long. This is a spot. If you go below Point Edgecombe, it's like southeast Alaska, there's a pinnacle south of Sitka. Comes up to about 90 feet of water, and then it just drops off. And it was never fished very heavily. Now it's illegal to fish. And there are hundreds of big lingcod at the crest, just at the crest of this little seamount. And they're doing this. And I actually have a photograph where they're stacked on top of each other, all in the same direction. And what they're doing is they're waiting for little rockfish to be wafted up by currents up the crest, and then they shoot out, grab it, and then slip right back where they were. It's really amazing. But what's interesting is that almost certainly this is the way things looked here before people were fishing. And we have so few places to actually know what quote-unquote natural looks like, but this is the way things used to look like. Next. Inside. Lingcod are also nest guarders. The males will guard the fertilized eggs. Females lead. Females come into shallow water, lay their eggs. Males fertilize them and then guard them for weeks and weeks and weeks until they hatch. There's lots of reports about how different male lingcods have different personalities. Some of the ling males will lie right on the eggs. Some of them are just hyper. A diver comes, they'll bite them. Some of them are kind of lackadaisical and looking around and whatever. There are actually reports of foster parents where a male is killed and another male will come over and watch them. It's really, really complex. Next. Cabazon. You guys have cabazons. Have bright blue flesh. Nice reef fish. Cabazon is a sculpin. There's like dozens of species of sculpins. This is one of the biggest. Most sculpins are in this size. Cabazon. The most interesting thing about cabazon is that red mass right there. Those are eggs. The eggs come in bright colors, reds, oranges, sometimes bright blue, but always really bright colors. And the rumor for many years was that they're toxic to eat. So Carl Hubbs, the ichthyologist at Scripps, back in the 50s, ate some. And then he wrote up what happened to himself. He wrote, it was basically, soon after I threw up. And I had diarrhea, and I threw up again, and I had diarrhea, and I threw up. Did I mention I had diarrhea? There was a lot of that for about 2 days. And it turns out there's a toxin that's in these eggs. It's found in only one other thing in the world, which is a little eel blenny that lives in Japan. And they're not related to each other at all. There's like, I don't know, 20 million years of evolution. But separately, these animals evolved that particular toxin. Next. This is how little we know about fish. So this is Lepsius bilobus, and actually, I've forgotten what the name is. I don't know if I even knew the English name. But anyway, this is a sculpin that lives here and further north. And a diver sent me these photographs. He says, I see the juveniles of this associated with jellyfish a lot. And it's probable that this is actually a real phenomenon, that these fish are kind of hanging near the jellyfish for protection. Once they get maybe like 4 inches long, they don't need the protection anymore, and they go down and live in the rocks. But like this has never been described before. Next. So that is intertidal sculpin. Basically, it's not smiling at you. It looks like it's smiling, but this is out of the water, and many sculpins can breathe air as long as you keep them down. When the tide goes down, you'll actually find them under rocks and so forth. You open up a rock, and there will be. This is a nice typical example. Next. So that's a lingcod, and inside its mouth is a scaly head sculpin. This is another undescribed behavior that only divers know about. Basically, this sculpin is cleaning the lingcod, and the lingcod will allow it into its mouth to pick out diseased tissue and parasites. I've seen the photographs of ones where it's sitting right on the lingcod's head. And I mean, cleaning is a worldwide phenomenon. Many, many fishes and invertebrates will clean others, and they're almost always protected against predation. But again, only divers have reported this. It's never been, no one has ever scientifically written about it. So that's a sea anemone, and that little fish up above is a painted Greenland, which are also found here. This is another nice symbiotic relationship. This is one of the few fishes on the Pacific coast that seems to be immune to the stinging tentacles of sea anemones. So you find the juveniles, that's a juvenile, but you also find the adults that are just hunkered right down on the sea anemone. Apparently, the stinging cells can't infect them. Next. Wolf eels. You got a lot of wolf eels up here. There's a lot of mythology about wolf eels because you see them, generally see them in pairs, the male-female pair, male on the left, female on the right. And because of observations in the aquarium in Vancouver, there was this kind of myth that, oh man, they stay together for 30 years. And it turns out, no, not really. They'll stay together for a few months or a few years, and then they split. But still, it's kind of cool. You find them in lots and lots of crevices. You can always tell where they are because there'll be all these shells of crabs and urchins and stuff around this cave, even if you can't see the fish. That's where they'll be. Next. So this is the Blackeye Gobi, which is very abundant here. Blackeye Gobis change sex. Blackeye Gobis start life as females and become males if they live long enough. Next slide. This is our equivalent. This is a sheephead, which is a kind of a wrasse, lives in Southern California. That's the juvenile. Next. That's the female. Next. And that's the male. So in fish, sexuality in many families is very plastic. Fish change sex. On occasion, they'll change back. It's not like mammals. And often it's an environmental cue that causes them to change sex. The classic case, a guy named Ross Robertson, who's at the Smithsonian Panama Lab back in the 60s. He was looking at the little cleaner fish that live in the tropics. And you always see the same thing with the cleaner fish. They're little cigar-shaped fish. The biggest one is always a male. And then there'll be a bunch of other ones. There'll be some females and then some juveniles. But the biggest one is always a male. So what he did was he took a net and he scooped the male out and put it in an aquarium. And the biggest female became a male. Real fast. It started acting like a male within a day or two, picking on everybody else. And then it actually changed. Its gonads changed in the course of a few weeks. So clearly, the big female was kept in check by the male, right? Remove it. So what he then did, and this is a very harsh thing to do, he took the original male that was in the aquarium and he put it back in the water. And the new male reverted back and became a female again. So, and you can have that fish go back and forth until she becomes a nun. It's really Sea perches, you have lots of sea perches. This is probably your most abundant one. This is the shiner perch. Find them in big schools, really common in eelgrass beds, places like that. And all the sea perches, and there's a couple dozen of them, are viviparous. And that is a viviparous animal. The female feeds the young in utero, right? We are viviparous. But what we have is we have a placental connection to the embryo, to the fetus. Fish don't. At least these fish don't. What happens is the female produces nutrients in her uterine wall, and the uterine wall is kind of plastered against the gills of the fetus, and the nutrients go through her wall and into the gills and feeds them. So the young, next slide, there's a young one being born. They're born fully formed, functioning little fish. That one's being born tail first. In several species, the males are born mature. They can actually mate as soon as they come out. And there's been a number of studies done by people at UCSB, and they always see the same thing. The young males immediately go for the biggest female they can find of that species, right? And they are always unsuccessful, always. And that's because, like, what kind of pickup lines can you get when you're in the uterus, right? I mean, what's your sign? That's about it. It's not going to work. Next. This is one of the most abundant fishes in our area. This is called Blacksmith. I presented it mainly because, well, for several reasons. First of all, it's what's in the background is an oil platform. Oil platforms just look like underwater, like humongous reefs, brilliantly colored. Whatever people think of the oil industry. And the other reason I present this is that it gives you an example of how a scientist who's describing new organisms works. So when I was doing my postdoc in LA, people started coming and saying, we're seeing all these dead blacksmith on the bottom at Catalina. They all had these big sores. No one knew why. So we collected some, and I hooked up with a bacteriologist at USC, and it turned out it was a new bacteria, an undescribed species of bacteria. And because we discovered it, when we wrote the description up for a scientific journal, we got to give it its scientific name, right? So what's our scientific name? Homo sapien. What's a dog? Canis familiaris, right? So that's kind of the genus and species. And basically I discovered a new species, so I knew the genus was Vibrio, and I called it Damsella because it infects damsels. The only thing we could find that we could infect with it at the time was damselfish, so it was Vibrio damsel. And it turns out it infects all kinds of things, even kills people. But at the time, that was it. So if you discover a new plant, fungus, fish, whatever, and you describe it, you get to give it its scientific name. I actually once described a parasite after my girlfriend. So basically, I was working on the parasites in rockfish, and I found one that lived in the heart of rockfish, a little protozoan. I thought, this is great. C'est très romantique. I'm going to name this after my girlfriend. And I was talked out of it. And I was a grad student. What the hell? So, but then I discovered two more protozoans. One was in the gallbladder of rockfish, and one in the urinary bladder of rockfish. And I said, the hell with this. One of these I'm going to name after my girlfriend, Regina. So I went home and I said, you have your choice. Which one do you want? She picked the urinary bladder. So I described a little protozoan called Debicia regini after my girlfriend, who I later married. Now, it turns out, once you're divorced, you can't change the name. So, just letting you know. Letting you know the facts. So, all of this was developed by a guy named Linnaeus, who was, actually his name was Carl Linné, who was a Swedish botanist about 1750. And he set this whole mechanism up for describing animals. He was, he was probably a sociopath, actually, but certainly a narcissist, a very unpleasant man. But his methodology was extremely sound, and that's what we all follow. The best scientific name I ever heard, had to be explained to me, was one Linnaeus gave to a sea anemone in about 1860, lived in the North Sea. He called it Priapus equinus. Okay, only one person right there knows who what Priapus is. Anybody want to? Well, I'll just say. Priapus is a Roman god of fertility. It's a guy. And in statuary, he was always a naked guy with an erect fufu. And in some cases, they would paint the fufu red and use them as roads, this way to Rome. Why can't we do that today? I would remember street names much better, or directions. The third fufu on the left. You can't one with the spangles on. Okay. So that's Priapus, and Equinus is horse. So I'm going like, what? You put the two names together, and it's bright red horse fufu. You're going like, huh. So this is the days before the web. I had to dig out some textbook, and it's an animal. It's about this big, and it's tubular, and it's red. You're going like, yeah, could be a horse fufu, sure. So that was the best thing. Next. Just a couple other fish. We're almost done. This is a cicad. The group is called blennies or eel blennies. This is a war bonnet that's very abundant in your area. This is a group of cold water fishes. By about Central California, they start pooping out. They're really abundant here, all the way across the Pacific to, not to China, but to Japan. There are members of this group, and all the way around the Arctic Circle, Beaufort Sea, and then all the way above Russia and so forth. There are members of this very cold water group. And a lot of them do that kind of stuff, where they tuck themselves into crevices. That's a barnacle, but that's just as good. I'm sorry? How big is a barnacle?
It looks like a barnacle.
It is a barnacle. Yes. Excellent. Gold star for you tonight. This is a snailfish. Many kinds of snailfish. Usually in deeper water. And this is one of the only images from life that anyone has ever gotten. They're actually rather lovely little animals. But mostly we get them in trawls, and they're all banged up, and they look like hell. It's really refreshing to see them when they're alive. Many of the snailfishes, the females lay their eggs inside the carapace of crabs. And then the male fertilizes them, and then the fish leave, and the crabs walk around with them until the larvae, we assume the larvae leave. And it's a great place. It's like giving birth in a tank. Like, who's gonna bother you if you're inside a king crab? Like, nobody. There's no predation on a big king crab. So it's a great place to put very delicate larvae, or eggs. Next. A couple of deep water fish, and we're all done. This is a lanternfish. These are fish that, again, live in many, not always, but in many cases, many thousands of feet down. They have little light organs, and they're probably one of the most abundant group of fish on the planet, because virtually anywhere you go in the world's oceans, you'll find at least one species of lanternfish. Some of them come at night all the way to the surface, but mostly they're down 1,000, 5,000, sometimes 10,000 feet down. Next. This is called a fangtooth. Looks like someone took a Vulcan hammer to its head, right? They're only about this big, but they have humongous teeth and jaws, because when you live that far down, let's say a mile down, there is not a lot to eat down there. So you want to make sure if you grab something that it ain't going to get away. So a lot of the animals down there have they're able to disarticulate their jaws, and they have big teeth, just because they have to. Next. So that's the last slide of fish. So this is a deep water anglerfish. There's that little lure up on the upper right. These things live, again, a mile or two down, and they have bacteria that are only found in that little lure. That's the only place anyone's found them. And they glow. The bacteria glow blue-green. So obviously these fish, they're in the dark. They're waving it around, hoping to attract something. So that's it. So they're a typical anglerfish. But what's unusual is the thing over on the lower left. The big fish is a female, and the little fish is a male. Right? So basically the male is a parasite on the female. We think they start out life as separate fish. And when the female starts to mature, she lays down a pheromone, a chemical trail, and the juvenile males pick up on it and swim right up to her and bite her right there, right by her vent. And in some species, the male never lets go. And in the extreme case, the female's circulatory system busts into the male, and the male kind of degenerates until there's not much left but a little sack of sperm. That's all that's left. So that's the second tattoo I got. And I got it because, first of all, it's a great story. But I got it because often I've probably given that story literally hundreds of times. And if you have enough people in the audience, you can actually hear a gender difference in the response to that story. The females are laughing. The males are going, wow, that's really interesting. Right? And the females are probably laughing because they've had parasitic males that are horribly, can't get rid of them. And the males are going like, it's my dream come true. So there you go. Okay, you've been very brave, all of you. And if you have time for questions?
Or do you want to do your video?
Oh, eso sí, Maria. Thank you. So here's the deal. So historically, when people bring rockfish up from deeper than about 80 feet of water, what? Hold it. Hold it. Stop it. Stop it. Okay. Way to go. A little sneak peek. So basically, when you bring rockfish up from deep water, they have a swim bladder, and the swim bladder expands. The gas is under pressure, and it forces their stomach out of their mouths, and their eyes bulge out. And historically, people have thought, well, these are like toast. These fish are dead, right? But it turns out it's not true. If you get the fish, not toss them on the surface because they drift away and get eaten. If you bring them back to the depth that you caught them, everything goes back into place. And the survivorship is amazingly really high, considering how awful they look. So that research was done in the last 8 or 10 years. And one of the women who, she got her PhD studying, it's called barotrauma. And a woman named Elena Preble, who went to Oregon State University, she did a lot of work on it. And she called me, she works for National Marine Fisheries Service now. She called me about 6 months ago and she said, I want to do a video showing anglers how they can get fish back to depth. Because most anglers still think you catch a rockfish, it's dead, even if it's an illegal one to catch, and you have to toss them overboard and a pelican eats them. So I go like, she said, you want to be in the video? And I said, well, I've been in a lot of videos. I don't want to be, but my puppet, my rockfish puppet does, right? My wife actually made me years ago a rockfish puppet that I use that talks, and he talks like this. And I said, the rockfish puppet would love to be in the video. So she said, great. She got Ray Troll, is that the Troll boy? No. Ray Troll, the artist, to write a rap song about barotrauma. And then, shot it, and we had John Dutton, who's a really, really good video editor in Hollywood. He did all the cutting and stuff. And then it's been about a month. It's been on YouTube and a bunch of places. So I thought I'd just kind of show you, first of all, it's kind of a fun video, but mainly it shows you how research can actually lead to something very substantive. In this case, greater survivorship of a whole family of animals. Now you can do it. Or now you can't do it. Okay.
How they let some of these videos on the web. I gotta go because you never know. Oh, checking out some. No, I mean a Moican. What can I do for you, Willie?
Well, I was wondering, have you ever heard of something called barotrauma?
Barotrauma. I didn't know you could pierce your skull like that.
No, Rockfish. It's a condition that happens when you're reeled to the surface by the fishermen. It's what happens when your swim bladder gas expands so much, so you're almost like a rockfish balloon at the surface. It's when the gas fills you up that your eyes are popping out of your head and your stomach's coming out of your mouth. Let me show you a little video we have on the subject. I think you need to see this.
Ever wonder why a rockfish gets barotrauma? Rockfish have a small bag of gas inside them called a swim bladder, which helps control buoyancy. When a rockfish is captured and reeled to the surface by a fisherman, the gas in the swim bladder expands and escapes into the fish's body through small tears or ruptures. The built-up gas pressure forces the eyes to bulge, and the stomach is often pushed out of the fish's mouth.
Oh, that's a nice red. You can see that this fish is suffering from some barotrauma because his eyes are averted, popped out. He's not just surprised to see me.
I think I had that happen to me once, but I thought I'd eaten a bad zombie.
I've already got my limit, so I'm gonna throw this one back.
If you throw this rockfish back into the ocean, it will just float away, because the excess gas makes it too buoyant to swim back down on its own. Often, these floating rockfish are eaten by birds or other marine predators.
That guy looks like toast. I wonder if I can get his rock.
Okay, wind up in here. We've got to get going. We're catching too many of the wrong kind of fish here.
The best thing to do is avoid catching rockfish that have to be thrown back. So if you're catching fish that you don't want or that aren't legal to catch, move on.
Yeah, that's great. But what about old Popeye over there?
Okay, guys, if you're catching too many of the wrong kinds of fish here, just tell the crew members and they'll use the deep water releases to let your fish go.
What is a deep water release?
A deep water release or recompression device is any device that helps the fish descend in water, preferably as close as possible to the depth it was captured. The research scientists in this video are lowering a rockfish with barotrauma back down to the depth that it was captured. As you can see, the excess gas inside the rockfish actually recompresses, allowing it to swim away. Their research has shown that even severely bloated fish can survive if released to deep water within 5 minutes. But the quicker the better.
Fish recompression.
Alright, so I'm gonna release these using the milk crate method. Try to handle the fish as little as possible when unhooking and placing in a release device. A fish's slime helps protect them from infection. The more you handle the fish, the more of the slime that comes off. And there's some technique in keeping the fish in the milk crate so that they stay floating up in the upside down milk crate once it's in the water. A weighted cage such as a milk crate may also offer rockfish a bit of protection from sea lions or hungry lingcod on their way back down. And then we'll let them down to depth. So I've actually counted out 40 handfuls at about 2 feet per pole. This is roughly 80 feet, and you see the line is tending to stay slack. It's way down there. And now the line is tight. So I'm going to go ahead and pull the crate back up. And the fish are back home.
So, that seems okay if it's quite shallow or not too windy, but that's not always the case.
When I fish deeper water, I like to use a Shelton fish descender to release fish.
Some fishermen use this device to release several fish at a time.
Now, in order for this to work, you need to hold the weight up in the air to keep the fish on the hook. Down he goes. And using the Shelton fish descender, it allows me to release my fish that I'd like to release, and then continue to fish once I'm down on the bottom with the 2 baited hooks.
That's good. How about when everybody's puking their guts out because it's so rough?
There are several fish gripper devices available, but the weather, the size of the fish, and the bottom type will affect how well they work.
This is a black tip catch and release device. It's one of several lip gripping devices that are available on the market. It works by opening the jaws and closing them over the lower jaw of the fish.
Then you simply put the fish over the side in the grippers and lower the fish down slowly. It's important that the weight hit the bottom solidly in order to get the jaws to open. It's also important to make sure that there is adequate tension to keep the jaws shut as the fish is descending. This is a Rockfishes fish releasing device. The Rockfishes is a good choice if your fish are from small to medium size.
You open the jaws, close it over the lower jaw of the fish, lower the fish over the side, and when you get to the desired depth to release the fish, you give a quick tug on the line, the jaws open, and the fish swims away.
The sequelizer can be set to release at any one of 3 pre-programmed depths. The jaws clip together like so, and at the programmed depth, it releases. The sequelizer can be used on even larger fish.
Whoa, nice video. Not enough car chases for my taste, but that's a nice video. Hey, Elena, before you leave, you want a sardine? They're imported from Cuba.
No thanks. It's a little early in the day for me.
Nice to see you, kiddo. Now, where was I?
Small but meaty. No, that was, so it's now, it hasn't gone like viral, but it certainly got the attention of the sport fishing community, which was the goal. Yes?
Can they go down too fast?
No, that's a good question. Can they go down too fast? No, you want them to go down really fast. Because basically, the longer they're at the surface, their gill filaments have collapsed. And so they're essentially choking. There's not enough air getting over their gills. There's some, but not enough. So you want to get them back in the water so that the filaments start to flare out, open up like this, so that water can go through them. And you want to get the depth so that the amount of damage that's being done is minimized.
And all those, or most of those devices are available commercially?
Yeah, that's the reason we picked them. I know nothing about this stuff, but the guy who did most of the talking, Merritt McRae, who's my graduate student, he actually owned a sport fishing boat for like 25 years before he went straight, and so he selected. Any other questions about the talk, or just a lot of sullen faces? Where's the tattoos?
The second tattoo.
Oh, I have to pull my pants down. No. Give me a private showing. Give me a dime. No, they're both right here on my arm. Yes.
Yeah, I was wondering, in all your undersea escapades around these oil rigs, what have been your observations down there? Good,
Okay,
bad,
so the basic findings from California oil platforms, and we've looked at virtually every one of them, is that as far as fish are concerned, they just act like really big reefs. But the difference is that they're better nursery grounds for rockfish, and that's mostly what we see. They're better nursery grounds than most natural reefs because they're much bigger. And when you have a little rockfish in the water, drifting around looking for a place to settle out, it's much easier if you're in over 500 feet of water. It's much easier to find a 500-foot platform that goes to the surface than a reef that's 500 feet down and is only 5 feet high. So they tend to be much better. They have much higher densities of little rockfish around them, and then they're not fished as much as natural reefs. So they tend to have bigger fish around them than most natural reefs. But in most respects, they're just great big reefs. We did a study looking at are the fish around platforms more polluted with like heavy metals than natural reefs, and they weren't. It was all the same.
And yet you noted that bacteria was around one of those. The bacteria you discovered was around.
Oh no, that was at Catalina. That's a natural run, and basically, it's in the water all the time. And what Blacksmith do in the springtime, they make little nests, put their eggs, and they bite each other for territory. In any place the slime has been broken, the bacteria, which are always there, get into onto the flesh that way and infect the fish. So that wasn't at the platform. Sorry for that. Yeah.
Going back to the midshipmen.
Midshipmen.
They agree with the certain nutrients. Does that affect the mating behavior, or is that?
Nobody knows. The mating behavior was not based on bioluminescence. The mating behavior is based on sound. The function of the bioluminescence appears to be counter shading. Basically, these things come out at night, and maybe they come up to about 200 feet of water, 300 feet of water. If you're underneath a fish in 300 feet of water and there's moonlight coming down, you'll see the fish because it'll be a black object against the moonlight. But the midshipman, the spectrum of light matches the moonlight. So they basically disappear if you're underneath them, and it's a way of avoiding predation. Any other questions?
Are they more highly predated up here then?
Nobody knows. No. A lot of, and that would be a little hard to tell. Unless you did a massive food study and see how often they appeared in the guts of fish, and it'd have to be the same species of fish, predators, and wow. So the answer is nobody knows.
Do the two populations mix?
No, apparently not. You get them commonly to about off Humboldt Bay, and then almost never on the outer coast of Oregon and Washington. And then in the Salish Sea, they're back. But if you look at their DNA, they haven't been separated long enough to see any differences in mitochondrial DNA. So they don't mix, but they're not genetically separate. At least we think they don't mix. Another question? Okay, guys, you've been very brave. Thank you.
Thank you.